Everybody, welcome to another Colin support video. This one's on graphing linear relationships word problems. So let's go take a look at these. So it says a battery with 20% of its full capacity is connected to a charger. Every minute that passes, an additional 5% of its capacity is charged. Graph the relationship between the battery's capacity in percent charge and the time in minutes. Okay, so X is your minutes, and the battery charges basically this y-axis. So my hair's kind of funny. Let me fix my hair. Okay, is that better? Oh, it's still puffy. No, whatever. Anyways, so a battery with 20% of its full capacity is connected to a charger. So where does it start? It starts at 20%. So you're going to start with the y-intercept of 20%. And then it says here, every minute that passes is an additional 5%. So it's gaining charge in every 1 minute that passes. So as X changes by 1 minute, Y changes by 5%. So that's basically what you're going to do here. So starting at 0, 20, then at 1, you'd be at 25. At 2, you'd be at 30, and so on and so forth. So at 1, you're going to be at 25. So this is the graph right there. And that's how you do it. Okay, the next one says, Mr. Mole burrow lies 5 meters below the ground. So where does he start? He starts at an elevation of -5. Okay. He started digging his way deeper into the ground, descending 3 meters each minute. So every time the minute increases by 1, his height decreases by, is it 3? 3 meters each minute. So basically, he started at 0, -5. And then as we go to 1, it would be at 3 less than that. It's hard to graph that. At 2, it would be 6 less than that. Hard to graph that. So let's think about where would be an easy place to graph, right? So you have here increments that are like basically 2.5 for every little line, and every 2 lines is 5. So you're really asking yourself, at 3, right, meters each minute, right, what would be a multiple of 3 that's going to equal to 15? So I'd say 5, right? So if you did 5 times 15, so we go to 5 here. So 1, 2, 3, 4, 5. So basically, 5 minutes into this process, he'll be 15 meters below where he started. So what's 15 meters below -5? -20. So this is the way I would kind of do it, because you need to find the exact points to graph. So because you're trying to find exact points to graph, and you're counting basically by 5s, every other one is 5 on the y-axis, then you want to have an integer order pair here that's where the y value is a multiple of 5. So if you start at 5 and you add some kind of multiple of 5, you're going to end up with a multiple of 5. So that's kind of what we did here. So basically 1, 2, 3, 4, 5. 5 minutes in, he's gone down an additional 15 feet, because it's 3 feet descending per minute. And so that means he's 15 feet below where he started. He started at -5, so he ends up at -20, and this is your line. Okay, Suraj took a slice of pizza from the freezer and put it in the oven. The oven heated the pizza at a rate of 7.5 degrees Celsius per minute, and it reached the desired temperature of 80 degrees Celsius after 12 minutes. Okay, so in this case, what do we know? We know that he put it in the oven. We don't know exactly what temperature it was when it was put in the oven. The oven heated the pizza at a rate of 7.5 Celsius per minute, and it reached a desired temperature of 80 degrees after 12 minutes. So we know that it's going to be the temperature of 80 degrees at 12 minutes. So you're going to take this first dot and put it at 12 and put it at 80. So basically after 12 minutes, right, in this oven, we know that it is temperature of 80. And we also know that it basically was getting hotter at 7.5 Celsius per minute. Now, when we look at our y-axis here, it's counting by basically 10s and 5s, so 5, 10. So you need to get something where you're going to have easy place to plot. So 7.5 isn't going to work, but if you double 7.5, that's 15, right? So what do we know? We know that 2 minutes prior to 12 minutes, right? So let's go 2 minutes prior to 12 minutes at 10 minutes. We know it's going to be 15 below the 80. So 80 minus 15 would be at 65. So we know this is the situation, basically, that we're starting at here, right? That basically after 10 minutes, it's at 65. After 12 minutes, or 11 minutes, it's going to be 65 plus 7.5, which is going to be 72.5. And then after 12 minutes, it's going to be at 80. And so this is kind of the slope that we're talking about here. Every time the x increases by 1, the y increases by 7.5. Every time the x increases by 1, the y increases by 7.5. And we know that it finished at 80 degrees Celsius at 12 minutes. And so that means it must have been at a constant rate of heating. It must have been at 10 minutes, only 65 degrees. So that's kind of how it goes. The y-intercept is obviously -10. So that basically means that the bread before it was baked was at -10 degrees. Starting value at 0 minutes. All right. Wilbur landed his plane, causing it to descend at a rate of 0.2 kilometers per minute. He reached the ground after 10 minutes. Graph the relationship between the plane's elevation relative to the ground in kilometers and time in minutes. So it says that he reached the ground after 15 minutes. So basically what that's telling you is that his elevation is 0 after 15 minutes. So when the minutes is 15, his elevation is 0. So that's his x-intercept basically, right? And then it says here that he's doing descending at 2.2 kilometers per minute. Now, what are the units we're using here? It looks like 0.25, 0.5, 0.25 again. So counted by 0.25 here. So you really want to think about when would he be at 1, right? So if we think about it, if it's 0.25 of those would get to 1. So basically 5 minutes prior, he was at 1. So if this is at 15, then at 10, he was at 1. Right? So I think this is what we're talking about here, right? So it says Wilbur landed his plane, causing it to descend at a rate of 0.2 kilometers per minute. So it's going down at 0.2 kilometers per minute, which means if it goes down, has 5 minutes to go down in terms of the x-axis change. The y-axis would be 1 unit, right? Because 0.2 times 5 is 1. So that's the last part of the descent there that we can see. And like we talked about, after 15 minutes, he is on the ground, which is right there. So that means he started his descent up at 2.5. So he was 2.5 kilometers up in the air when he started to descend. But that's not what they asked, but just for fun. There you go. So this is the correct way to do it. Oh, did I do something wrong? Interesting. What did I do wrong? Wilbur landed his plane, causing it to descend at a rate of 0.2 kilometers per minute. He reached the ground after 15 minutes. So there's 15 minutes. There's the ground. That makes sense. Okay, I must have made a mistake with where I placed the second dot. Let's see what mistake I made. So this is 14, 13, 12, 11, 10. So 5 minutes prior, 5 times 0.2 will be 5. I'm doing that right. 5 times 0.2, I believe. 5 times 0.2 is going to be 1. All right. Let me investigate this for a second, guys. Hey, everybody. So I didn't really make a mistake at all mathematically. I just made a mistake where I placed the dot. So I placed it here, right, because I wasn't being careful. There's the 1. So, yeah, that's where it should have been placed, guys. So he started at 3 kilometers up in the air. I just literally placed it here because of being sloppy. So don't be sloppy. Make sure you place the dot where you're thinking the dot goes. I told you guys it would be at 1 when it was 10 minutes. 1. That's where it should have been. I placed it here for some reason because I was just careless. All right, so now we got it right. That's how you do it. Don't make my silly mistake. Do better. All right. Let's stop the video now.